Welcome to CCO Studios in Coláiste Ciarán.
Hi, I'm Nene, and here I have
Sarah-Jane
and Rosemary.
And Sarah-Jane and Rosemary won BT Young Science. Can you tell us about your product?
So we designed a ketchup stand to be able to take the long-necked bottles and hold them upside down in a cabinet without them falling over, and doing this would reduce plastic wastage and reduce food wastage.
Why did you think it was a good idea?
Because we noticed that we were washing a lot of ketchup down the drain when you're washing out the bottles.
Yeah.
So we wanted a way around that.
Around pricage wise, how much did it cost?
Not a lot, I don't think so.
Did you enjoy making the product?
Yes, it was fun because we spent a while just sitting in the science lab thinking about random ideas to come up with to get as much waste out of a ketchup bottle as possible.
How did you work as a team?
Well, we obviously split the work evenly, and then we found times that would work for us to stay after school and work on the product.
So you guys won 2 awards at BT Young Science. Can you tell us about it?
So one of the awards that we won was our category award, which was the Junior Chemical, Physical and Mathematical Sciences. And then the other award we won was the Williams Lee Award for our presentation of our report book and our video.
That's really good. Would you ever recommend another student to do BT Young Science?
Yeah, it was one of the most fun things I did this year because, apart from missing all the classes, we got to do something that I genuinely enjoyed,
Yeah.
and the actual experience of the young scientists was really fun.
Well, thank you for being here.
Hello, I'm Sarah-Jane.
And I'm Rosemary. We are second year students in Coláiste Ciarán Croom.
Our project is an investigation into the amount of waste sauce left in a bottle after the user thinks it's empty. We came up with this idea after noticing how much ketchup we were washing down the drain when a bottle was finished.
But why is this a problem? The more waste sauce left in a bottle, the more often it needs to be replaced. The long-term consequence of this is that more plastic is generated in providing the world's population with ketchup, mayonnaise and mustard. We decided to design an investigation to see if it would be possible to design a bottle that would reduce waste to a minimum. The first step in the project was to do a survey. We found out that many people share our concerns about waste and that most people prefer upside-down squeezy bottles to other containers.
We collected lots of sauce bottles from our homes and from teachers in school. We wanted to make sure the experiment we were doing was a fair test, so we put every bottle upside down for 2 hours before starting. We then squeezed the last bit of sauce out. We then needed to find out how much waste sauce was left in the bottle. We weighed each bottle on a sensitive scale. We then washed each bottle thoroughly and placed it in a blast dryer to ensure it was completely dry, and weighed it again. We also measured the neck diameter and spout size of each bottle with the vernier calipers.
We then analysed our results. We found that the wider the neck of the bottle, the more waste sauce left in the bottle. We also discovered that the spout size did not really affect the amount of waste left in the bottle. From our observations, we felt that the thinner sauces left less waste behind. We are going to extend our study to compare viscosity with the amount of waste left.
So our results told us that the most wasteful container, the upside-down squeezy bottle, was the most popular with consumers. We set about trying to find a solution. We brainstormed better designs for the upside-down squeezy bottles, but it was difficult to design one with a small neck diameter and a stable base. The designs we came up with would have required a lot of extra plastic. Making bottles with extra plastic would go against the aims of our project.
After more brainstorming, we came up with the idea of making a reusable stand to put upright bottles into upside down. This would mean they could be stored upside down, making them convenient to the user but would not fall over in the cupboard. We 3D printed our design.
This is our design. It is a wide base with a sponge insert. This would allow bottles with different neck sizes to fit into it. We are still working on improving this design, but we are happy with our progress so far. Thank you.